Okay, we'll begin. Just a few logistical things. Okay, well, I guess I should introduce myself. Hello, my name is Miles Chen. Okay, and I'm excited to be your teacher during the summer. Summer is always a bit more intense than regular session because we're trying to fit 10 weeks of stuff into 6 weeks, and so just don't skip class. Keep up to date in all of your work here. This is the textbook we're using. Do you guys have this book? Yes? No? Maybe? Okay. You do not need, if you bought the textbook from the bookstore, you do not need the MyStatLab stuff, okay? If you can just get the text from any retailer online. I know Amazon rents these textbooks also for a pretty good price. You just want to get Introductory Statistics by Robert Gould, Colleen Ryan, 2nd edition. That's the book that you want to get, okay? You don't need the MyStatLab stuff. You can save yourself some money. It doesn't have to be new, anything. That's fine, okay? So this is me. This is my email address. All of this is all posted on our class webpage. Actually, maybe it's better if we go there. Let's log in. Okay, and so you will have your TAs, Spencer and Tristan. They're both excellent. They really know their stuff, so you can always reach out to them. The syllabus has been posted, and so no, okay, of course not. Let's see if I can take a look at this. Just kind of, okay. Because I teach a few stats classes and I also teach through UCLA Extension, please make sure somewhere in your email you are saying you are Stats 10, okay? Stats 10 Session A or something like that. That will just help me kind of put your email into a proper context. The grading for this class will be as such, 15% quizzes, 15% lab assignments. We'll have a midterm and a final exam. Just one midterm, one final, and then 10% quote homework. There's going to be, I won't be using clickers during the summer. I normally use clickers during the school year, but not during the summer. So you can either return those or give them back to your friends or whatnot. As far as the quizzes, we will have 3 of them. They're going to be worth 5% each. Do not miss or skip your quizzes. Try not to be absent. As far as lab assignments go, we're just going to have 3 of them. It's summer, so things are a little bit more compressed. Again, 5% each. Don't not do a lab, okay? Do all of your labs. The labs are really there just to kind of, they're meant to help your grades rather than hurt your grades, okay? So so do them. Don't skip those out. Skip out on those, okay? As far as homework goes, I will assign homework problems from the textbook for you guys to do, but I will not actually be collecting them or checking to see if you have done them, okay? So at the end of the quarter, I'm going to give everybody 100% for their homework grade. I did this in the past. No one seemed to have complained about it. As far as the homework goes, though, you should do the problems, okay? If you don't do them, you are just really cheating yourself out of a learning opportunity. And, you know, when you come to office hours, if you're telling me you're struggling with the material, I'm more than happy to help you, but one of my first questions will be, let me see how you're doing in the homework. And if you come to office hours and you say, well, I didn't do any of the homework, I will say, well, I think that's probably why you're struggling with the material. So, you know, I'm here to teach you all of this, and I feel very privileged to do so, but I also expect you guys to do your part. So as far as textbook goes, yeah, this is the textbook you need. It looks like this, and you'll need a calculator. It does not have to be a graphing calculator, but I do recommend at least a scientific calculator of some kind. Whoops. I'm still okay there. So I just use a calculator that looks kind of like this. This I got maybe 13, 15 bucks on Amazon. You can, if you have a scientific calculator already, that's great. If you don't, I recommend that you get one. The only rule I have about calculators is it cannot be your cell phone, okay? And you'll need them. The labs will be covered in your lab section. That will be handled by your TA. Any questions you have about the labs, ask your TA first, okay? I've delegated all responsibility for the labs to the TAs, so so your TAs are the first people to ask about the labs. Okay, these are the dates that we will have quizzes, so make sure you come to school on those days, and then the midterm exam will be where do I have it? Monday, July 11th. Okay, and the final will be Wednesday, July 27th. So make sure you have those dates marked in your calendar. Don't schedule anything else. Okay. Okay. Any questions about the syllabus before we begin? We're good? All right, then we shall start. I don't know. Okay, so let's. This is Introductory Statistics. This is my one of my favorite classes ever. I love teaching this. When I took Introductory Statistics as an undergraduate student, it literally changed my life. I don't know if this class will have the same effect on your life, but perhaps. So I started off as an engineering major. I completed my undergraduate studies in engineering, but after taking Introductory Statistics, I really enjoyed the subject of statistics. I took more statistics classes, and then after graduation, I worked for a couple years, but decided I wanted to come back to graduate school to study statistics, and I completed my PhD last year, and here I am teaching statistics here at UCLA. I feel like this is my dream job, where I get to teach statistics and work with you guys. UCLA is like the best school ever, and so I'm really happy to be here and to be teaching. So I hope you guys like the class. I hope you enjoy the material. I know, some of you might be coming to this class feeling like you are, quote, not a math person, or that you've never liked math, and that's okay. Statistics is different from other math classes. There is obviously going to be some calculations and numbers involved, but a lot of it is reasoning and thinking about data, and so it is, in that regard, different from a lot of other math classes that you've had, and I hope you enjoy it. If you've already taken like AP Stats in high school, this class might at times feel a little bit boring because it covers a lot of the same material. But otherwise, if this is your first stats class, I hope I present it in a way that you find interesting. Okay. So this is Introductory Statistics, and I will just write a little heart. I love statistics, which you should put in your notes as well. So let's start off with just kind of maybe a question you should ask at the beginning of any course you take, which is, why are we even taking this class? So why do we study statistics? Okay. And I claim that we study statistics and I'm hoping all of you guys can see this and read this okay? All right, okay. Those of you in the front, I apologize. You might have to crane your neck. It's like being at the movie theater in this auditorium here. So we study statistics, I say, to gain a better understanding of the world around us. And everyone can hear me okay? Those of you in the back? You guys are good? Okay. Okay. And this could actually, the fact that we gain a better understanding of the world around us could be said about a lot of the classes that you take, you know, history, political science, psychology, all of these teach you something that helps you understand the world a little bit better. But in particular, statistics allows us to make conclusions from limited data. Just save this. This is okay. And so let me explain what I mean by it allows us to make conclusions from limited data. So let's say we have some kind of research question, okay? Okay, and the question could be something like, you know, does a new experimental medication, we'll say, help lung cancer patients improve, you know, more than currently existing medication. Okay, so we can ask something like this. This is a difficult question to answer. And to answer this question, we have to think about, first of all, before we can even get into setting up an experiment and collecting data or things like that, we first have to think about the relevant population. We first have to think about the people that this question is relevant to. Okay, so first, think of the population, okay? And the population would be all the people who are relevant to this question. And when I say all the people, I really mean all the people, okay? Or if we're not talking about people in terms of lung cancer patients, it's like all of the objects or all of the things relevant to the question. So in this case, who is the population?
People who have cancers.
Yeah, it would be all lung cancer patients. Okay, so anybody who has lung cancer. Okay, so their population. Okay, would be all people all people with lung cancer. And as far as these things go, populations are almost always too large for us to study them directly, okay? So all people with lung cancer, that, you know, that could be a lot of people, all right? And so I'm gonna write populations are almost always too large for us to study directly. Okay. If we do study the population directly, it's called a census. Okay. Studies on the actual population. Is called okay. But otherwise, you know, I mean, we would love to see if we could look at all people in the population, but you know, testing out an experimental medication probably isn't even ethical to try to test this out on everybody in a population, okay? Because maybe not everybody wants the experimental medication. And so we have to deal not with a population, but just a select group from that population, okay? Is it all right that I just flip the slide here? No? Okay. That's why I asked. All right, so we'll flip back here. Okay, I'll let you guys catch up on your writing. I will post, so I'm recording a video of this lecture, and I'm also saving all of these notes, and I'll post them online as well. So I think it's good to write them down in your notebooks, but everybody learns a little bit different, and so if you learn better by just sitting back and listening and paying attention, by all means do that. The notes will be online waiting for you, okay? If you like to write things down yourself, you know, kind of process the information, then that's also good too. So whatever fits you. Okay, can I move on here? All right, all right, you gotta speed up. All right. Okay. So I'm going to write because populations are too big, okay, we will take a sample from the population and study the sample. And so kind of just, here is this blob, and this is the population, too big to be studied directly. This thing is too big. Okay, and so instead of dealing with the entire population, we're just going to take a tiny little piece. Okay? out of the sample, out of the population, this thing is called the sample. We're going to zoom in on this piece. Okay, and we're going to, this is an eyeball here. Okay, so we're gonna study the sample. And based on what we see in the sample, we will try to make conclusions about the population. Okay, and so that process where we've observed the sample, and now we are going to try to make conclusions about the population. This is called statistical inference. Okay. And this is what I mean by trying to make conclusions based on limited data. Okay, so perhaps, you know, we managed to set up an experiment. Okay, you know, we get 50 people to volunteer for our experiment, and in this experiment we we give half of them the currently existing medication, and then the other half we give them the experimental medication. Okay, and then we see how well do the people recover in for those taking the experimental medication and those taking the regular medication. Okay, and so let's say, I don't know, out of 25 people taking the regular medication, 10 of them improve, and out of the 25 people taking the experimental medication, let's say 15 of them improve. Okay. Does that then mean that overall the experimental medication is better than the currently existing medication, or not? Okay. And these are tough questions to answer, because we can say, well, 15 people improving is certainly better than 10 people improving. But then there's a question of, well, how did we pick these people? We just, we got 50 volunteers, and we just randomly assigned them to one group or another. And it could just be, because of random assignment, maybe a total of 25 people were destined to improve in their conditions anyway, okay, whether they got the current medication or the experimental medication. And there's this question of, could the results that we got just be a weird thing from random luck? Was it just luck that happened that the experimental medication showed better improvement? Or is it the fact that the experimental medication actually performs better than the currently existing medication? These are questions that we can't just look and say, I have a feeling or I have a hunch, but we'll have to understand some of the underlying probability and statistical reasoning behind it. Okay, and so that is the direction that we're headed in this class. We've got a lot to cover first in the view of descriptive statistics and probability and all of that. So Anyway, so this is what we're doing. We want to make conclusions based on limited data. Okay. Let me throw in, if we want our conclusions based on the sample to be valid about the population, okay, then our sample must be representative okay, and if our sample is not representative, okay, samples that are not representative they are biased samples. Okay. Just waiting for you guys to catch up. Okay. The truth is that it is quite difficult to get a representative sample. Okay. Okay. And you can take a course devoted to this topic of trying to get a representative sampling. It'll be a class on sampling methods. You can devote your entire life to this study, working for an organization like Pew Research, or where they're trying to get representative samples. Okay. One method that should, but is not guaranteed, to give a representative sample is called simple random sampling. Okay, and so with simple random sampling, okay, we start with a sampling frame. Okay, ideally, the sampling frame is a list of everyone or everything in the population. again, the population is everyone relevant to the research question. Okay, so ideally the sampling frame is a list of everyone in that population. But it's very difficult to obtain this true sampling frame, okay? So, you know. Okay, and then and what we do is with the sampling frame is we randomly select people one by one from the sampling frame. Okay, so we randomly select people one at a time. Okay, and when I say randomly select, I mean randomly select, okay? Not arbitrarily. So if you just kind of close your eyes and say, maybe this and then this and this, that's not random, that's arbitrary, okay? Random means we're using some kind of random generating device. Maybe, you know, you're rolling a die, or you're putting pieces of paper into a hat, or you're using a computer to randomly select values, okay? This would be, you know, a true random method. Okay, and if you do this, then every person in the sampling frame has an equal chance of being selected. Okay? And then every single possible sample has an equal chance of being selected. Okay, so what does it mean that every possible sample has an equal chance of being selected? You can think of the lottery, okay? So in the lotto, there's like, I don't know, 60 balls floating around in some kind of tank, and then they're just bouncing around, and then the machine just randomly selects which balls get selected, right? 6 of them get selected. So every possible set of 6 numbers has an equal chance of being selected. So the numbers, the lotto ticket 1, 2, 3, 4, 5, 6 has an equal chance of being selected as, 10, 25, 36, 40, whatever, some other set of 6 numbers, okay? All possible combinations have an equal chance of being selected, and that would be a form of simple random sampling, okay? Except probably your population is going to be much bigger than 60 numbers or something like that. Okay? Is that good? Okay. So a lot of times when we talk about sampling in the future of this course, we assume that it has been done via random sampling, simple random sampling, okay? Which might not always be a safe assumption when it comes to real life data, because getting a truly random sample requires that we have a good sampling frame, which is actually a very difficult thing to do in real life. So, if I gave you a homework assignment and I said, get a random sample of 20 people from the city of Los Angeles, this would be a nearly impossible thing for you guys to do, because can you guys think of any way to have a sampling frame for the city of Los Angeles? Phone book? Okay. How many of you are listed in the phone book? Yeah, so okay, so none of you would have a chance of being selected if we were to use the phone book as a sampling frame, okay? Probably a better sampling frame these days would be Facebook, if they were to, you know, give us access, full access to whoever logs in from a Los Angeles located IP address or something, but of course they're not going to release that to us. And then not everyone's on Facebook either, so it's truly something hard to do, okay? We might, cell phones, if we were somehow able to access all the cell phone towers in Los Angeles and see all of the cell phones that ping a tower, we might be able to randomly select some phones, and that might probably be the best way, but that would require access to certain infrastructures that we probably don't have access to, but maybe the NSA can do that, okay? All right, let me just give a brief course overview. Okay, and so in the beginning we are going to cover this topic called Descriptive Statistics. And it's this, it's kind of a broad topic, and here the idea behind descriptive statistics is we take data and summarize it. With a few values, okay? And that will take us through about maybe chapter 4 in our textbook. We'll look at different types of data. And then, and once we finish descriptive statistics, we'll enter the topic of probability. Okay? And probability tells us how likely or unlikely particular events are. Okay. If we understand probability, we can move on to this topic of probability distributions. Which is, it's a related topic telling us how likely or unlikely certain values, not just events, but certain values are to appear. And then an extension of probability distributions is sampling distributions. Okay, and sampling distributions tells us basically the probability of getting particular summary values. Okay, so in descriptive statistics, we learn how to summarize values, and then over here we learn probability, and we're going to learn how to the probability of getting a particular summary value. Okay, and once we have that, we can take the summary sampling distributions along with our descriptive statistics, and we can perform statistical inference. Okay, and with statistical inference, we can say, I've observed certain data with these summary values. I've calculated the probability of getting those summary values. Well, if I combine that information together, what insight does this provide about the population? Okay. We combine our understanding of summary values and their probabilities to make conclusions about the population. Okay, and so I would say the descriptive statistics and probability distributions, this will probably take us up through the midterm exam, and then sampling distributions and statistical inference will be the second half of the course. Okay, I'm going to flip slides here. All right, so let's talk about data. All right, and we can often think about storing our data in a data table. Okay. Okay, and the way I want us to think about data tables is that in our data tables, okay, each observation should have its own row. Okay, and each observation, or observational unit, I should say, okay, you might have different measurements or different things, different bits of information recorded about each person or observational unit. Okay, so each observation or each person or and each observational unit or person may have several pieces of information recorded. Okay, and so each of those pieces of information is a variable. Okay, and each variable will have its own column. Okay, and so for example, we could have a table where maybe we have a name, okay, and we have I don't know, Audrey, and maybe we'll record this person's height and weight and maybe age, hair color, and I don't know, eye color. Okay, so maybe Audrey is 64 inches tall, weighs 128 pounds, is 21, has brown hair and brown eyes, okay? And then maybe we have Bill, who is 71 inches tall, weighs 182, is 20, has blonde hair, green eyes, etc., 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 okay? So each row, these are our observational units. Okay, and in our columns, these are the variables. Okay, we can classify the variables into two types. We have numeric variables and we have categorical variables. Two types of data. We have numeric variables. Okay, numeric variables tell us how much or how many. Okay, and we have categorical variables. And they tell us what type or what kind. Okay, so on the previous page, I think I had height. These are the variables that I had. Okay, and so we can go through and the name. This is like, this could be a categorical variable, but it's a special kind, and this could be our identifier. Okay. All right, height. The way it was recorded was in inches, and so this was numeric, recorded in inches. Okay. Weight was also numeric, recorded in pounds. Age was recorded in years, and these are numeric. Whereas hair color and eye color, these were categorical. Okay. A thing to note is that variables could be categorical or numeric just depending on the way they're recorded. So age is not always necessarily numeric. Variables can be numeric or categorical depending on how it is recorded. Okay, so if somebody tells us their age in years, that's numeric. Okay, so usually, you know, if someone says, "How old are you?" they're expecting a numeric response generally, right? I'm 27 years old, I'm 56 years old, whatever, okay? They're expecting a numeric response. If, however, if you are doing demographic information or something, age can be recorded something like this, 0 through 12, okay, 13 through 17, 18 through 24, 25 through 40, 41 through 59, et cetera, et cetera, et cetera, okay? And they and you get classified into these different categories, and they say, this TV show is popular among this demographic, okay? It's popular among people between the ages of 13 and 17. It's a certain TV show, or whereas another TV show might be popular among those, in the 25 through 40 demographic or something like that, okay? So, or, in politics they say, this candidate is popular among 18 to 24-year-olds, but not popular among 60 plus or whatever, okay? So, in this case, if age is broken up this way, this would be, categorical variable. Okay, so we have this concept of a numeric variable that is then being treated as a categorical variable. Okay. If I were to ask you, if we had another column, we said, what is the area code of their phone number? Is this a numeric variable or a categorical variable? It would be a categorical variable. Okay, area code would be categorical. Why would it be categorical? Okay. Yeah, it doesn't tell us how much or how many. Okay, it doesn't make sense to say my area code is 818, your area code is 310. I have 508 more area code than you. These types of comparisons are meaningless, okay? Whereas you can say, I have 4 siblings, you have 1 sibling, I have 3 more siblings than you. That is a fair comparison. That's a numeric variable, okay? Or you could say, I'm 30 years old, you are 20 years old, I am 10 years older than you. You can say that. That is fine. Those types of comparisons are fine when you're dealing with a numeric variable. Whereas when you're dealing with categorical, those types of comparisons don't work out. Okay. Okay. We can summarize. Let's see. We can summarize categorical data using frequency tables. Okay. And so when we do this, we will deal with counts. Okay, so the underlying data is categorical. Okay. Okay, the underlying data is categorical. But when we summarize it, we're going to use counts, okay? We use counts and proportions. Okay, so for example, we could ask, give me a summary on, let's say, hair colors. And the count we will call frequency. And so we could have, you know, black hair, brown hair, blonde hair, okay? And, you know, clearly there's some kind of spectrum here. We'll say red hair, and then we'll say other. Okay, and then so I don't know, I'm just making up some numbers here. Okay, so here, this is our frequencies. We have a total, I think, of 100 people. Okay, and we can have proportions, or sometimes this is called the relative frequency. Okay, and this would be a proportion of 40%. This may not have been the best example to have a total of 100 people, but basically you just take your count and divide by the total number, and you'd have a total proportion of 1, okay? So this would be called a frequency table. Frequency table, and also a relative frequency table. Okay. You can have also what we call a two-way table. Okay. Maybe we took data on whether someone is left-handed or right-handed, okay? And I know there's ambidextrous people, but just for simplicity, we ask them, what hand do you use to write most of the time? Okay. So we have left-handed and right-handed people, and then and maybe we asked some other categorical variable. Maybe we'll ask sex, and we have, you know, male and female, okay, and then yeah, we'll throw in you know, other, or, you know, something, you know, did not chose not to respond, whatever, okay, and we can have I don't know, 10, 12, and 1, and I don't know, 70, 80, and 5, and we have a total of 23 and 155 and 178 total, okay? And this would be 80, 92, and 6, okay? And so this would be a two-way table, and here we have broken out the total numbers into you know, we had a total of 23 left-handed people and 155 right-handed people, but that can further be broken down into, you know, genders or sexes here. Okay, and so this would be a two-way table, and this is these are just ways we can summarize our categorical data. All right, so far so good. There is often a question of how do we gather data in the first place. Okay, so here I just kind of presented some data and said, you know what, look at this. We've got data that we can summarize and things like that, but, you know, how do we even get data in the first place? Okay. And so, as far as this class goes, we can look at observational studies or experiments, okay? I guess there is another kind called anecdotal evidence. Okay. And anecdotal evidence, these are like, you know, I know someone who this happened to, okay? Or, you know, you read a customer testimonial, you know, like, this is like, I know someone who, you know, I know someone who decided to undergo some unusual treatment and they were cured of their disease, okay? Or, you know, customer testimonials fall under anecdotal evidence. You know, all sorts of stuff. And I don't want to say discredit anecdotal evidence and say these stories are not true, because they very well could be true. But as far as statistical value goes, anecdotal evidence does not have much statistical value for us, okay? Okay, so what is true and what worked for a handful of people may not necessarily work or be true on the grand scale for the entire population, okay? And so as far as anecdotal evidence goes, there's not a whole lot we can do from a statistical perspective. Okay, but we do have observational studies. And as far as observational studies go, what we do is we observe our subjects that we are studying. Okay. In general, we try not to interfere with our subjects, with the exception of taking measurements. Okay. Ideally, we record all measurements, or we record measurements on all aspects Okay, so ideally we record measurements on all aspects that could be related to the phenomenon we're studying. So if we want to know, what things affect the risk of type 2 diabetes, we would record everything about someone's life that could be related to type 2 diabetes. Things from, exactly what they're eating, how much sleep they're getting, how much exercise they're getting, what they're doing, their genetics, all of these pieces of information that could be related. How much time do they spend sitting, and how much time do they spend walking? All of these different things. Ideally, we record all of this stuff. Now, from a practical standpoint, it might be very difficult to get all of that information, right? If you signed up for some kind of study because you wanted to know your risk of getting diabetes, and they tell you, okay, we want you to log every single thing you eat. We want you to record exactly how many minutes you sat down today, and how many minutes you were walking, and how many minutes were vigorous exercise, and how long did whatever how much sunlight did you were exposed to. You would probably say, forget it, I don't want to have to record all of this. This is too much work. So there's obviously some kind of balance between the amount of information you can record and the data that you collect, that you want to collect. Okay, so we can probably think of hundreds of things related to the risk of diabetes or something like that, but it might be difficult to obtain all of that. So you just do the best that you can. Okay, and at the end of the study, okay, we might find some kind of link between the phenomenon, whether diabetes happens, and one of the variables recorded. Or we might say we might find an association between the outcome and a particular set of variables. Okay. However, we cannot say that one thing is caused by another, okay? But we cannot say that there is a cause and effect relationship. There might be a cause and effect relationship, but we cannot say that for sure. The data from statistics alone, we cannot conclude that there's a cause and effect relationship, okay? Trying to conclude a cause and effect relationship requires a deeper understanding of whatever it is that we're studying. We would have to, if we want to know, what things are associated with or what causes diabetes, we would have to have a greater understanding of the inner workings of the human body and things like that. We might be able to find risk factors. We might be able to say obesity is linked to a higher risk of diabetes. We might say, eating diets that are high in sugars and things like that might be associated with a higher risk of diabetes. But we cannot say for sure that eating lots of sugar causes diabetes unless we have a deeper understanding of the mechanisms in there, okay? A silly example of why we cannot make a cause and effect relationship from an observational study, here's a silly example, is let's say you were an alien visiting a hospital. Alien from another planet, okay? You don't know very much about human life or culture, and so you are observing what's happening in a hospital, and you notice, okay, that there's a man who wears black robes, carrying a book with a cross on it, and sometimes he will enter a room, and there will be a person, and maybe he will say, recite something, say some words, and maybe the person on the bed will also say some similar words, and then shortly after that person dies. Okay, and you see this happening over and over again. Okay, you've spent several weeks at the hospital, and this is a common thing where you notice the man with the black robes going into a room, saying a few things, and then the person dies shortly after. Okay, in an observational study, you would say, okay, there is a increased risk of death after this man in black robes enters the room. Okay, but is the fact that a priest goes into a room and says a prayer causing people to die? No. Okay. If you're Catholic, there's kind of this a ritual or thing known as the last rites, where you kind of say some prayers, or a priest will say some prayers with you, and this is usually reserved for someone who is on the verge of death. Okay, and so from an observational study, if you were an alien, you were to report back to the mothership, you'd say, we got to avoid these people in black robes. They seem to possess the power over death, or something like that. That would be the wrong conclusion to make, because from an observational study, it's not, you can't draw a cause and effect relationship. There's other variables, hidden variables or lurking variables there, that in this case, the overall health of the person that is in great decline, that is bringing about both death and prompting the priests to enter the room. So we can't say there's a cause and effect relationship, but people often like to draw conclusions about stuff like this. Okay, there's a lot of you'll often see news articles that say, like, there's been a link between cancer and eating some food product, or some kind of chemical or something that exists in a food product, and they'll say, okay, it seems like there's some kind of association there, and so suddenly people say, well, this is the thing that's causing it. Maybe not. We don't know. Okay. Okay, so that's observational studies. On the other hand, we do have experiments. Or maybe it's better to call them controlled experiments. Okay. And with a controlled experiment, the researcher assigns conditions, and the set of conditions are called treatments, to the participants. Okay, so in an observational study, the researchers just observed and recorded information, didn't do any kind of assignment of treatments. Okay, in an experiment, the researcher is saying, you are going to do this, and you, on the other hand, are going to do this. Okay. In the ideal controlled experiment, ideally, the researcher can control everything. Okay, obviously this is not possible, but the researcher can control all things that could be related to the outcome. Okay, And ideally, everything will be set, everybody will have identical conditions, okay? And ideally, everyone will have identical conditions except for the treatment conditions. Okay, and then so at the end of the experiment, okay, so let's say this is our ideal scenario, okay, where we said, okay, thank you for volunteering for my experiment. I've randomly flipped a coin, and this half of the classroom, you're going to drink soda every day for the next 10 years, and this other half you are not allowed to drink any soda, and we're going to see what effect this has on your development of diabetes. By the way, you also have to all have the same, everything else about your diet is going to be exactly the same. Everyone's going to get the same amount of sleep, everyone's going to have the same job, everyone's going to have exactly the same, everything is going to be made identical about your lives for the next 10 years. And at the end of the experiment, let's say this half of the classroom has a higher rate of diabetes than this other half of the classroom. Then we can say, well, because everybody was set under the exact same conditions, with the exception that this group had soda and this group did not have soda, therefore we can attribute the difference in diabetes rates to the fact that this group had soda and this group did not, okay? Now, that's an extreme scenario where we've controlled all aspects of your life, which is probably not possible on a practical level, with humans at least. But if you are going to do animal testing or something else like that, you can set up identical conditions across the board, okay? So at the end of the experiment, any difference in the outcome okay. And so it's in experiments that we use placebos to try to control for the psychological effect, because part of making conditions identical is that we don't want people to know which treatment they're receiving, so we use placebos, okay? Placebos and blinding are used. And with experiments, we can make a cause and effect conclusion. And I guess, if properly designed, but not all experiments are practically or ethically possible, okay? Okay. So, as there's questions about, what are the long-term effects of using marijuana? Like if you used marijuana every day for, 20 years, does this have, an effect on your brain? Maybe, maybe not. We don't know, okay? It's not ethically possible to conduct an experiment. We can't say, thank you for volunteering for our experiment, and we are going to now assign half of you are now going to smoke marijuana every day for the rest of your lives, and we will check back in on you in 20 years and see if this has affected your brain. Okay? That's not ethically possible. Okay? So right now all we can do is our observational studies, and we can just say, okay, we've looked at the brains of people who used marijuana for a very long time. Okay? And maybe, I don't know, okay, maybe we see something a little bit different about these people's brains. But then we have a bit of a chicken and an egg problem, right? Are their brains different because they've used marijuana for a long time? Or did they choose to use marijuana for a long time because their brains are different, right? These are questions that are hard to answer, that we cannot answer unless we do an experiment, but experiment is not ethically possible. Such an experiment is not ethically possible, and so as different states are debating about the legalization of marijuana, these are questions to which we don't know the answer to, and it's difficult to say one way or another. Okay, I'm going to why don't we just take like a 2-minute stretch break.